Okay guys, welcome back. So in the last video I talked about a simple explication of the ideal gas laws using a system when the pressure, volume and the number of moles were given, and we have to find the temperature. So we have to apply the ideal gas law and then find the temperature, right? So in this video I will be using the same example, right? Same example in which the pressure and the mass I will be using the same values, but I will now take the value. I will not be giving the value of n, right? So I have to find n, right? And I have to find the mass of the gas as well. Alright. So this is the question. So if I have a system like this, right? And I'll take the pressure, the same pressure I have been using in the last video. Right? The same pressure I have been using in the last video, so that is 3 times 10 to the power 5 pascals. 3 times 10 to the power 5 pascals, and the same volume, which is 2 cubic decimeters. 2 cubic decimeters. But in the last problem, I have to find the temperature. Now I'll take some temperature. I'll say 300 Kelvin, which is 27 degrees of Celsius. So approximately 27 degrees of Celsius. So what I am asking is, what is the number of moles of this gas and what is the mass of this gas if the molar mass, or capital M, is I will take 60 grams per mole. Now there may not be some gases in which the molar mass is 60, right? Molar mass is 60, and there may be sometimes, but I'm just taking an arbitrary value. Now don't confuse what is the gas I'm using here, right? I'm just taking an arbitrary value. So what is the number of moles? What is the value of n and what is the value of n? So since the value of n changes, now again I have to apply the ideal gas law, right? So from ideal gas law I can say PV equals nRT. PV equals nRT, right? So if PV equals nRT, first of all we have to find the value of n. So I'll isolate n. So n equals PV divided by RT. N equals PV divided by RT. So I can substitute the values here and find n. So n equals PV. So P is equal to 3 times 10 to the power 5. P equals 3 into 10 to the power 5 pascals. And V is equal to 2 cubic decimeters. So as in the last video, what I have to do, I have to convert this into SI units, because I am going to take this in moles, right? This in moles, so I have to convert this into SI units. So the SI unit of volume is cubic meters. So the value of V has been given in cubic decimeters. So we have to convert this into cubic meters. So 1 cubic decimeter, as I mentioned in the last video, is equal to 1 into 10 to the power minus 3, or 1 upon 1000 cubic meters. So 2 cubic decimeters will be 2 into 10 to the power minus 3 cubic meters. So we have to substitute that here. So that will be 2 into 10 to the power minus 3 cubic meters divided by R I'll take as 8.3 again. So it will be joule per Kelvin per mole times the temperature. So the temperature of the system has been given as 300 Kelvin. So the temperature is already in the absolute values. So I don't have to convert into absolute values. So I can directly substitute that here. So that is 300 kelvins. So Kelvin per Kelvin to Kelvin cancel, and as I mentioned in the last video, the unit combination, or the product of Pascal times cubic meters, is equal to the unit of joule, right? Unit of joule. So I'll get, now this is per mole, right? 1 upon per mole is equal to moles, so I'll get the answer in moles. So I have to simplify this. So n equals, so 10 to the power 5 times 10 to the power minus 3 is 10 to the power 2, right, 10 to the power 2, and these two zeros, that means 3 times 10 to the power 2, and this 10 to the power 2 to this 10 to the power 2 in the numerator will cancel. So the answer, and this 3 to this 3 will be cancelled. So the answer will be 2 divided by 8.3 moles, right? 2 divided by 8.3 moles, so that will be approximately 0.25, right? I will not substitute, I will not solve that, right? So this is the equation, right? So this is the solution, right? This is the solution. So n is 2 divided by 8.3 moles, right? I'll use a bracket. I'll use a bracket, otherwise it will be confusing to you. So n is equal to 2 by 8.3 moles, so I have found the value of n. So my next intention is to find the value of m. Now you know that the number of moles for a gas, right? The number of moles for a gas is equal to its mass divided by the molar mass, right? So n equals m by m. So this is a very popular equation. So if you are well versed with chemistry and the other concepts, you may have already heard this, right? So n equals m by m. So we have to find the value of m. So m equals simple m. So m equals n times capital M. M equals n times capital M. So we have to find the value of m. So we have found the value of n and we have been given the value of m. So m equals n, which is 2 divided by 8.3, 2 divided by 8.3 times the molar mass, which is 60. So that will be 120 divided by 8.3, which will be approximately 15 grams, right? So very small, yeah, right? 15 grams. So if you supply, conversely, if you supply 15 grams, right? If you apply 15 grams of this gas to this system at some pressure and volume, you can get the temperature at such a temperature, and at some pressure and temperature you can get such a volume. So that's the converse of this problem and converse of this solution. So that's another application in which ideal gas laws comes into play. So in the last video I talked about a situation in which we have to find the temperature given the number of moles, the pressure and the volume. So in this video I used the converse thing. I gave you the pressure, the volume and the temperature. We have to find the number of moles, and not only the number of moles but also the mass of the gas as well, given the molar mass. So these two videos, this video and the last video, were two applications in which ideal gas laws are used, and in the next video I'll be explaining you a new concept on the gas laws. And thanks for watching this video, and see you then.